Welcome to Chip Chat, an interview series that connects you with technology experts around the issues that industry is focused on today. And now your host, Allison Klein.
Welcome to Chip Chat. My name is Allison Klein. I'm joined today by Jim Elliot from Samsung. Welcome to the program.
Hey, thanks, Allison.
Jim, why don't you tell me what you do at Samsung?
So I'm currently the Vice President of Memory Marketing and Product Planning here in North America.
Fantastic. The topic for today is green memory, and we're going to talk about what Samsung has been doing in green memory. But before we get there, can you set a context for what has been the general trend of memory usage in the data center and virtualization and its impact over the last few years?
Data centers in the U.S. consume more electricity than all of the televisions in the United States at this point. So we see this area as really being ripe for innovation by utilizing some advanced DRAM technology. Virtualization is going to be key because with more and more virtualization, you have a much higher requirement on the memory footprint per CPU. Mm-hmm. And so as you get more and more virtualization, especially within the IT server and data center areas, you're going to see an increasing need for memory, particularly at the higher densities.
Why do IT managers care so much about energy efficiency within the data center? Is it just saving money and being responsible from a standpoint of green programs, or is there something else at play?
You know, there's a lot of things that they're interested in. There's obviously saving money from a power standpoint. There is a cooling area to think about. A lot of times the rule of thumb we use is for every dollar you're spending on power, you're spending an additional dollar on cooling. And there's also the physical space constraints.
Samsung has been talking about green memory. Can you tell us a little bit about your interest here and what green memory means?
Memory really represents a significant portion of the system power consumption in the server space. Mm-hmm. If you run the numbers, it's about 26% or more than a quarter of the power consumption at a typical 48 gigabyte deployment. So this has really been a large contributor for what we call data center energy drain. So green DDR3 memory is going to offer IT managers much greater energy efficiency, especially at the 1.35 volt level.
Can you tell us a little bit about the 1.35 volt versus the 1.5 volts for those who aren't familiar with the memory technologies?
The main voltage rating for DDR3 is currently 1.5 volts, but we also have a 1.35 volt offering, which is going to have an additional power reduction of an additional about 18% relative to 1.5 volt. So again, it's just one more way of taking more and more additional power out of the energy equation.
How much power do you estimate that IT departments can save with the 1.35 volt DDR3?
So if you compare a 1.35 volt DDR3 using the 4x nanometer lithography load in a 2 gigabit density, and you compare that to some of the legacy install base, which is using a DDR2 solution, we can actually realize a power savings at the chip level of about 73%.
Wow.
And at the system level, at a 48 gigabyte system, you're going to see a power usage reduction of about 38%, simply by going to the most advanced lithography node, 1.35 volt DDR3. If you look at the U.S. install base of servers, it's about 12 million servers in the U.S. So if we replaced every single one of those servers that are by and large using legacy memory with the more advanced green DDR3 technology, you could save almost 30 trillion watt hours per year, which is about $2 billion.
That's pretty incredible. What systems that are coming on the market today can use green DDR3? Are there any limitations there?
So right now, the Intel Xeon 5500 and the 7500 platforms work with DDR3, as well as the newly released Intel Xeon 5600 CPU core.
How do you see memory and things like solid-state drives impacting servers in the future?
Yeah, that's a great question. I think when you combine SSD and DDR3 together, that's a very powerful combination. And if you think about SSD, you're talking about significantly higher performance, higher performance per watt, higher IOPS per watt of electricity use, and you're also going to greatly reduce your overall server storage and power footprint by switching over to SSD.
What can we expect from Samsung next in terms of this space?
So again, we are very aggressive in terms of ramping up our 4x nanometer class 1.35 volt 2 gigabit process, and we're also looking at a 4 gigabit component density later in the year, as well as taking that lithography node down even further to drive additional power savings.
Well, thank you very much, Jim, for coming on the program. Great leadership from Samsung here with Green Memory, and thanks very much for telling the audience about it.
You're welcome. Thanks for having me.
Visit ChipChat online at intel.com/design/chipchat.htm.